What I want to do now is talk about reference angles. And let me first of all just show you, I've got this angle sketched here, 135 degrees right here. So it's this angle here. Now, when we talk about the reference angle, we would be referring to this angle. I'll call it alpha. In other words, this angle right here, the angle made with the x-axis on the other side. So we've got 135 degrees, and then we have what's called its reference angle. Now, let me show you how this works. Let's suppose we want to find the 6 trig functions for 135 degrees. That's what we want to do. Well, you know, if we were talking about an angle less than 90, we could make a right triangle, and you know, we could say sine is opposite over hypotenuse, tangent's opposite over adjacent, and so forth. But this is 135 degrees, so we're not dealing with a right triangle here. However, we can deal with the right triangle if we think about the reference angle. So let me just show you with this example. Think about this point up here. This point is the point -3, 3. Okay, that's that point. I've sketched it out here. And notice we've got a triangle over here. Okay, I can make a triangle. And notice this. The sine of alpha is going to be the opposite over hypotenuse. Well, here is the adjacent, here's the opposite. The hypotenuse up here is going to be the square root of 18. So here we've got this. We've got the opposite over the hypotenuse. And of course, I can simplify that. This is going to be 3 over, well, this is 9 times 2 in here. So this would be 3 over 3 square roots of 2. So this is 1 over the square root of 2. Now I could rationalize the denominator, although I don't have to. Multiply the top and the bottom by the square root of 2, and I get square root of 2 over 2. Now, we know from the unit circle, of course, that is indeed, that's the sine of 135 degrees. It's also the sine of 45 degrees. Yeah. So notice, we're saying the sine of 135 degrees is exactly the same as the sine of 45 degrees. Okay? And notice what I was just working with this angle right here, this reference angle. I wasn't even thinking about the 135 degrees. Now we can also get the cosine, okay? Cosine of alpha. But here we have to be careful because, well, let's just keep it the way it is. Notice we've got adjacent over hypotenuse. -3 over the square root of 18, and that would be negative square root of 2 over 2. See, I worked through it just like I did before. And then let's go ahead and get tangent. Tangent of alpha is 3 over -3, which is -1. Now notice the similarity here to the angle, the 45 degree angle. In fact, let me see if I can move some of this over a little bit. Move that over a little bit. Think about if we were dealing with the 45 degree angle. Okay, let's just move it up here. Okay, so this would be if we were dealing with 45 degrees. Notice that this angle here, I'll call it beta, is the same as alpha. So you can see how these reference angles work. It takes this angle that's not, you know, part of a right triangle, and we get an angle that is part of a right triangle. So instead of working with 135 degrees, we work with 45 degrees. However, we're careful to take note of the charge of the trig function. For example, in quadrant 2, cosine is negative. Sine is positive, tangent's negative. But this is called a reference angle. Now here's how we find the reference angle. It's going to be let's look at this first one here. We've got 180 degrees. Okay, that's if we go all the way around here. And we're subtracting off the 135. And that leaves alpha. So that gives us a 45 degrees. This is the reference angle. So we work with finding the trig functions of 45 degrees Being careful of which quadrant we're in, though. Okay, we're in quadrant 2, so cosine's negative, secant's negative, tangent and cotangent are negative. So this is how we do that. We find the angle, the acute angle that is made with the x-axis. So let's see how this works with 225 degrees. Now our reference angle is this right here, this angle. So notice how this would be. We would take 225 minus 180. And if you work through all of that, you're going to get 45 degrees. Okay? 45 degrees, that is our reference angle. But in this case, over here, you've got sine is negative, cosine's negative, and of course secant and cosecant's negative, but tangent and cotangent are positive. But notice, in quadrant 2, I took 180 minus the angle. Okay? So in quadrant 2, I took 180 minus. If the angle is in quadrant 3, if the terminal side is in quadrant 3, then I take the angle minus 180. So quadrant 2, 180 minus the angle. Quadrant 3, the angle minus 180. See? Now what about quadrant 4? Well, in quadrant 4, this is our reference angle. This is our alpha. So what we're going to do in this angle is 360 minus the angle, 315 in this case. And notice what we get. We're going to get 45 degrees. Okay? So once again, all three of these have a reference angle of 45 degrees. But here in this quadrant, sine is negative, cosecant's negative, and tangent and cotangent are negative, while cosine and secant are positive. But what we would do, for example, in this quadrant here I go. I've got sine of alpha over here. Sine of alpha is going to equal the square root of 2 over 2. But we take note, okay, this is in quadrant 4. 45 is our reference angle, but this is going to be negative. Cosine of alpha is positive square root of 2 over 2. And then, of course, tangent is negative 1, and cotangent is negative 1. So that's the way these work. Okay, now let's look at another type of problem here. Let's suppose that we've got an angle. And I'll just draw a real quick grid here. So let's suppose that we've got an angle, and let's suppose it looks like this. Let's suppose that we've got a terminal side over here, okay? And this looks like it's 2, 3, okay? Negative 2, 3. See, over 2 and up 3, yeah. So let's suppose we want to find, and I'll call this angle theta, all the way around there. Let's suppose that we want to find the 6 trig functions for theta. And we have this. We're told that the endpoint of the terminal side of that angle is the point negative 2, 3. So the endpoint of the terminal side is negative 2, 3. So this terminal side right here, it's been rotated. I mean, it's, over to where the endpoint here touches at negative 2, 3. And we want to find the sine, cosine, and tangent. Well, look at this. Of course, this up here is 3. This is negative 2. And of course, this would be the square root of 9 plus 4, square root of 13. Okay? So let's see how this works. Now, first of all, we've got sine of theta. Well, the sine of theta is just, notice we're using this reference angle here. See, we're using that reference angle. So this is going to be 3 over square root of 13. Now, of course, cosecant would be the flip of that, square root of 13 over 3. Okay? Then we could talk about cosine. Cosine is negative 2 over the square root of 13. Secant is the flip, square root of 13 over negative 2. And of course, we've got tangent and cotangent, this is going to be 3 over negative 2. Cotangent is negative 2 over 3. So there's how we could find those. So this is, once more, this is an application of the reference angles. Now, one of the things that may confuse you a little bit here is, didn't we say that the sine is the y-coordinate and the cosine is the x-coordinate? Well, that's for a unit circle. It works like this. Let's just think about a let's consider an angle, and let me show you how it works. Let's suppose this is an angle gamma. Okay. Now, and we've got this point up here, x and y. Here's x and here's y. And notice that up here, this is the radius of the circle. Let's suppose we're making a circle, and this is not the unit circle. Notice that sine of gamma is actually y over r, and therefore r is r sine theta. Sine gamma. See, if we're talking about just a general circle, and this is y here, y would not just be equal to sine of the angle, it would be equal to r sine of the angle. But because in the unit circle, the radius is 1, we just have y equals sine theta. But it all works out. So look at this. Let's suppose that, let's just think about this. For this point right here, y is equal to 3. So let's do this. Let's take the sine of this angle, I'll call it gamma, and this is equal to 3 over the square root of 13. Now notice that 3 is equal to the square root of 13 times sine of gamma, which is r times sine of gamma. See, it works out, and that's what y is. 3 is y. So you see, yeah, we've got the case that y is equal to r sine gamma.